Hi guys, welcome to today's video. Today we're going to be talking about the three main softwares I use for designing and modifying STLs for 3D printing. So those will be TinkerCad, Zbrush, and Fusion360. So I'm going to do a quick high-level overview of what I use them for, and then we're also going to do a part design in each of those. So let's get into it. So TinkerCad is a free online software. It is basically a shape-driven software, so you can see all these different pre-made shapes here. There's a lot of pre-made stuff already in there, and you're basically dragging and dropping 3D shapes to create what you're looking for. I don't use this very often, but what I do use it for is editing existing STL files. So I find this really easy to add text or just to edit existing things. Like I did not design this miniature. However, I wanted to have a smaller base, so basically I brought it into TinkerCAD. I used a pre-made ring here or a tube and basically made it as a cutting action, so it cuts away this existing material, and then I can now export this as an STL with a much smaller base. So I use it for editing. If you're a visual person, I think this is great because you don't have to think about the different components. You can basically just bring different shapes in to make what you want to do and size it accordingly. Again, this is free, and we will get into some of the design work here in a second. Fusion360 is a software I use the most. I'm in this basically every day if I'm designing something. It's a really powerful tool. It's very engineering oriented, I'd say, for specifying dimensions. You can generate drawings, assemblies from it. This is a silo I built in the software for miniature gaming. So even though it's a very hard object, like rigid shapes, you can still make a lot of soft curves and other items. I just pulled this up as an example. There are free versions of the software. I also pay for this one since I do use it commercially. But again, this is my one I use day in, day out, the one I found easiest to use. And it's a software I really like. Just to show another feature of Fusion360, I really like this is a bit more organic looking. This is a sting blade I designed. And one thing I really like about this is you can import different components, turn them on and off, and it's a great way to make sure your pieces align properly. So I can turn components off, look inside, you can check for fit, align different items. So Fusion360 is great for assemblies, rigid parts, and again, I think this being a sword, it's a bit more, I'll say, organic looking, but not quite something I would need Zbrush for. So we can make rigid objects, assemblies, and do a lot of different cool things with this software. So that's part of the reason I like it so much. Again, you can turn off everything, you can export drawings. Very cool what you can do in this software. Now Zbrush I use relatively frequently. The advantage of Zbrush, in my opinion, is for organic shapes. Like I've sculpted this all in Zbrush, and you can basically treat things like a ball of clay. You can sculpt, you can move objects very dynamically to create all sorts of different shapes. It's a really powerful tool for, like I said, sculpting organic objects. Once we get in our example, I'll show you why Zbrush is not necessarily great for some other aspects, but Zbrush is a powerful tool for sculpting and doing a lot of miniatures or other very dynamic shapes. I do pay for Zbrush. There are some, I think, other subscription options. They've changed some things over the years with different tier levels, but I do have a subscription to this service.
So I thought it might be useful to walk through making an actual part in these softwares to show you what it takes to develop a kind of rigid part design in one of these. So I came up with this very basic part, a 2-inch cube with a 1-inch circular hole in it that proceeds 1 inch into the depth of the cube. So what we're going to do is I'm going to go through TinkerCAD, Zbrush, and Fusion360, and we're going to make this part in each of those and export it for 3D printing. So this is a very basic part. Shouldn't take very long, but I'll walk through it and kind of show you the strengths and weaknesses and how we have to make this part in each of these softwares. So let's take a look at that.
All right, as I said initially, TinkerCAD is a very shape-driven software. So if we want to add in a cube, we simply grab a cube from over here, drop it into our work plane. Now, this is not the correct size, but it is already a cube. Basically, you just need to click on the side you're looking to edit, click one of the corner dimensions, and we know a 2-inch cube in millimeters is 50.8. Change this to 50.8 as well. And then select here for the height, 50.8. And there we have a 2-inch cube, all set, ready to go. Now, again, being shape driven, to make a circular cut in here, we're going to grab in a cylinder. And this is basically, we're going to use this as a negative. So you can see here, we've got solid versus hole. So we're going to make this a hole, and once it joins in, it'll be cutting or moving material away. Now, one thing I like to do is make sure it is well off center. I want this right in the center, but we want to make sure this is aligned properly. So I'm going to select both of these by dragging my cursor over, and then click the align button, or you can use L. And you'll have these different dots here, and basically this translates to X, Y, and Z where you want it to align to. So if we want it center on the X, we'll click this one, center on the Y, click this one, and then there's another one up here that should bring it down to the level. Now, in this case, you can see it brought the cube up to the level of the cylinder. And basically what we have to do is then we have to drop down to work plane, so our object is now flat. Okay. So now that we're done with that, we still need to edit the cylinder. So if we want this to be an inch, 25.4, and then click the height on this one, 25.4. Now you can see in doing that, it broke our alignment. So what we could have done is made the size change earlier, or we have to go back, select these, go back to our align, center everything again, drop it back to work plane, and then now we've got our shape. The cut tool isn't very obvious here, but if we export this, we'll get a nice cube with our 1-inch cylinder cut here. So overall, pretty quick and easy. Again, if you know what you're doing, again, the shapes help a lot. If you're looking for, I think, an introductory to CAD and just want to mess around with shapes, I think TinkerCad is a great way to go. It's free. The shapes are a great visual cue to just add in what you're looking for. And it's actually pretty powerful for doing a lot of different features here. There's a lot of pre-made things. It's a great starting tool, in my opinion, if you want to get started making something. All right, so that is our shape done in TinkerCAD. If we want to make this to an STL, we just hit export, and we'll just click STL, and that'll export out to that. All right, let's move on to our next software. All right, now Fusion360 is a software that's primarily driven by 2D sketches, and those are extruded or basically made into 3D shapes. So as you can see here, there's no shapes to choose from. These are all just features. So really what we need to do is we need to start with a sketch. So I'm going to click Create Sketch, and then I've got these sketch planes to choose from. It really doesn't matter. Basically this one here, if you start your sketch on here, that will orient kind of automatically if you're going to 3D printing. So basically usually you want this to be your Z-axis, so the top of your print will be up here, and then the bottom of your print will be down here. So we're going to click on this one. It being a cube, it doesn't really matter that much, but that's what we're going to start with. So now that we're in our sketch mode, we now do have some other features to choose from. We've got some basic things like rectangles, we've got circles, ellipses, arcs that we can all use to basically make a basic sketch. So since we are just making a cube here, we're going to start with a square. I'm going to draw this out like so, and you can see a few things here. There's no dimensions on it. It automatically puts some constraints to make sure that these are rigid. So these notations here basically make sure it's oriented vertically or horizontally. But as it is right now, this shape can be moved to different dimensions. It can be moved all around. Nothing's really constrained in it anywhere. So a big part of this software is also making constraints. And what those are is basically making sure that once an object is placed, it essentially can't be moved, or there's definitions for why things are set the way they are. So once we have this in place, we're going to basically set these dimensions. So this is the dimension tool. So I can just click a side here that was already clicked from before. I click off, and then I just type in my dimension. So again, we know it's 50.8. And then I can click on this side, type in 50.8. And then now we've got our base of the cube. Now, one thing I like to do is this origin point. I like to center things. So what you can do is click your origin point, click an edge, and then you can set dimensions. Now, I could type in 25.4, but if I'm using something where I might change the shape later on and I want to make sure it stays oriented, I'll click this dimension, so it references this dimension here, and then divide it by 2. So your dimensions can also be equations to some extent. And then I can do the same with this side. So click this edge, click the center, click off to the side, click a reference dimension again, and then hit divided by 2. So now this square is centered on our origin. And then we're going to hit complete. So now we have completed this sketch. So we have a simple square here. Now this is still not a 3D shape. So now that we have the basic shape, we can hit extrude. It's already automatically selected this, but basically you can select your sketches. This is the only sketch we have. Select this and then type in our 50.8. And now we have our cube. So not too difficult, but it is a little bit less intuitive than TinkerCad. Now for adding in the cylinder, this is again, we're going to be making sketches again. So we start with the concept of a 2D shape. So I want to cut into the top. So I'm going to select the top of this, and that is where my sketch origin is going to be. Now, one nice thing, since we centered this previously on our origin, I can type in C for circle tool, and then I can just click on the very center of this, and it'll automatically align to that center part. I click off, and then I got to come back in with my dimension tool, and then type in 25.4, and now we have our inch circle centered in our 2-inch cube. Complete that sketch. So now we've got our circle sketch, and again we need to extrude it. So I click on that sketch piece, and then since I can either drag this and it'll come with a dimension, or I could just come to this side here and type it in. So if I want an inch depth, 25.4, and then we have our shape complete. So to make this 3D printable, I just need to save it. Call this test cube. And then we go to 3D print, click our shape, and then it'll export it out that way, and we'll have our design done. So again, not very intuitive, I would say, but once you get used to it, you can create a lot of complex shapes using different extrusions, different cuts, all these different features here. Again, it's a little bit more work intensive, but it's a very powerful software that I like. And again, I think it's very easy to dimension things and come up with rigid shapes. So that's Fusion360. Let's move on to the next one. All right, so here we are in ZBrush. There's a lot of different menus here, and in some ways ZBrush is a little bit like TinkerCad in that you can add in different shapes here. So if I go to tools, I can pick from these existing shapes. So if I were to grab this cube, I can pull and drop in a cube. But what's not really apparent is the next steps to work on this cube. So now if I go to click again, I'm dragging just more and more cubes around. I hit Control Z to clear these to go back. And once I draw my first cube, what I need to do is hit T for Tessimate, and then I need to make it Polymesh 3D. And now that creates this as a subtool, which is basically a tool I can work with. And now I can freely rotate this cube and edit it in different ways. Um, ZBrush took me a lot of tutorials to get to kind of basic understanding of this. So to me, even though some things like the sculpting, you can see I'm editing the top surface of this lightly, are kind of intuitive of the different brushes. There's lots of different brushes you can use and choose from. I think those are rather intuitive, but the different aspects, I just hit Control Z to get rid of that, are not very obvious in my opinion. And one other downside of ZBrush is that there's no easy way to set a dimension on this. So there's no dimension toolbar. There is no way to set a distance from A to B here. We know this is a cube, but I can't readily set the distance here. There are some tools in the Z plugin that you can work with. You can set different scales and kind of adjust sizes of things to fit so you can get pretty close, but it's not like TinkerCAD or Fusion360 where you can readily set the dimensions. You're always going to be tinkering things and getting kind of close. So to me, this example isn't a great highlight for ZBrush and what we're doing. But we're still going to kind of show you the process in this. One thing I like to do as well is materials always starts off with this red. I change the material to matte cap gray. I think it's just easier on the eyes and easier to see. All right, so now that we have our cube, we are going to append. So basically we're going to add in a cylinder. Oops, I click it just right here. And now you can see it added in a cylinder. It's meshed already with our cube. So what we can do is we can go to move and basically move our cube up, or we can hit Alt Tab and click on this cylinder. Now I want to take this cylinder, orient it up. If I hold Shift, I can move this in increments of 5 and then move this up so that way we are now kind of more in the center of this. I can use these sliders to adjust the Z, or I'm sorry, the X, Y, and Z, or scale the whole thing up and down. I want this to be more of a uniform scale, so I select this and basically slide the whole thing smaller. Now I know from if this was a 2-inch cube, if I hit Shift, I can bring this down to half the size. So I'm kind of cheating a little bit here using this to set it at half of what it was. So if we can assume an object we scale in our slicer to be 2 inches, if we make this half of that, this will be 1 inch. So not the easiest way to do it, but it is one way to do it in ZBrush. And then we just slide this flush here. Now right now these are just 2 objects. They are going to merge, and if I were to 3D print this, I could either export this as 2 separate objects, like I'll go to Z plugin, go back to my 3D print hub. You can see there's export options. So you can export to separate files. I click that off because I would want this all to export as one. But you can make every subtool export to different files. Now, right now, like I said, these are all unioned as one object. So what I need to do here is click basically this option here will make it cutting. So similar to ZBrush, similar to TinkerCAD and Fusion360, we basically use the cylinder to cut away. Now you can see nothing has changed here. Basically what I need to do is do live Boolean, and basically that'll show the changes live, and now we have a cut into the cube. And then now I can just go to Z plugin, export to STL, and then this will export out to my desktop. So ZBrush cube. And now that is exported out. So again, even though this isn't the strength of ZBrush, you're still able to do similar things if you kind of know, I'll say, what you're doing. Now, like I said, this will export out in a uniform shape, and basically I'll probably have to use my slicer to resize it up to 2 inches. So it's not a terrible way to do it, but it does take a little bit more work than Fusion360 or ZBrush for this particular aspect. All right, so one mistake I had made just a second ago was I thought I could export this with this cut boolean and I would be all set. Instead, I actually need to go down here and go to make boolean mesh, And once you click that, that will make a separate tool. It'll take a second. Union meshing in progress. And then once that's complete, I'll actually have to click a separate tool and then export that. So if I go up to my tools here, click my tools, I can click this. I've done this a few times just to confirm. Click this, and then now I have my union meshed cubes. You can see this one has the hole in it. And then now I need to go to Z the plugin, export to STL, go back to my desktop, replace the ZBrush cube I did before, and then now it'll have the corrected cube. So kind of a roundabout way to do it. Again, I don't think this is the most straightforward way to do this, but just want to show that in ZBrush this is certainly feasible to still to come up with rigid objects. Again, I think its strength is in the sculpting ability, not in doing kind of rigid merged objects like this. But certainly some people do hard surface modeling in ZBrush for armor and other things like that. So it's a powerful tool, but this example I don't think played into its strengths.
Well, guys, thanks for watching the video. If you have any questions about the software, please add them to the comments below. And as always, if you like this content, please like and subscribe for more. Thanks.